Hi guys, and welcome back. Yesterday we talked about zero exponents, and today we're going to talk about negative exponents. Now, let's trip students up. So we're going to talk through using some rules that we already know. So we know that 4 to the 5th over 4 to the 3rd is 4 squared, based on our exponent rules. So we did 5 minus 3 is 2. Okay. If we do 4 to the 5th over 4 to the 4th, we know that's 4 to the 1, because we subtract 5 minus 4 is 1. We know from today that 5 minus 5 here would give me 4 to the 0, which we know also equals 1. Okay? Now the question is, things start to change when we have a smaller number in the bottom. So 4 to the 5th over 4 to the 6th, that would be 4 to the negative 1. And 4 to the 5th over 4 to the 7th would be 4 to the negative 2. But we do not like negative exponents, okay? In the math world, they have decided that in a final answer, they never want negative exponents, okay? So we need to change that. So we know from this last problem that 4 to the 5th over 4 to the 7th is actually 4 to the negative 2, okay? But I want to be able to write that as a positive exponent, and we want to see how that can happen. So I'm going to write this as 4 times 4 times 4 times 4 times 4, like we know, because 4 to the 5th is just 4 or 5 times. And we can do the same thing with to the 7th power. Okay, so 5, 6, 7 here. Now, we know from earlier when we did this that the 4s start to cancel out to be 1, right? Well, what happens is I'm left with 1 on the top because there's no numbers on the top, so we can assume it's 1. So this would be 1 over 4 squared if I wrote it in exponential notation. So that means 4 to the negative 2 has to equal, 1 over 4 squared. So what that means is whenever we have a negative exponent and its base in the numerator, we can move it to the denominator. The same would be true if it's in the denominator to start with. We could move it to the numerator, okay? This is only if the exponent is negative. It has nothing to do if the base is negative, only if the exponent is negative, okay? So let's practice some of these. So 13 to the negative 4, this is really over 1. So this whole thing has a negative exponent, so I'm going to move it down. Since there's nothing left on top, it just becomes 1 over 13 to the 4th. Okay, so all I did, it was in the numerator, I moved it to the denominator. 5 to the negative 3, that's over 1 automatically. I'm going to move the 5 to the negative 3 to the bottom, and that becomes 5 to the 3rd. Okay, go ahead and try this one and see what you can come up with. So again, that's a negative exponent, and this is really over 1. So I'm going to take that negative exponent and its base and move it down to the denominator. Since there's nothing left in the numerator, we automatically put that 1. So once I move the base with its negative exponent, the exponent becomes positive. Okay? All right. This is usually the trickiest part when we're getting into exponents. Okay? Now let's practice if it's in the denominator, okay? So because this is in the denominator and it's negative, again, I don't want my final answer to have negative exponents. I'm going to go ahead and move it to the numerator, okay? Now I could write it as 13 over 4 or 13 to the 4th over 1. Either is the same, okay? That doesn't matter which way we write it. But because it was in the denominator, we move it to the numerator. Same with this one. We're going to go ahead and move it up. So this becomes 5 to the 3rd. Go ahead and try this last one. So this would become 2 squared. Okay? Again, we're doing this because we don't like negative exponents in our final answer. Okay? That's just how the math world has done that. Now there is a note, if the base is negative, so like if I had negative 2 to the negative 4, my base will stay the same. That'll still be negative 2 to the 4th. Only my exponent will change signs when I move it, okay? Not my base. Okay, that is very, very important and a mistake students make a lot. Okay, so the base will stay negative, but the exponent will change. Okay, so now let's go ahead and start combining our negative exponent property with some of our other properties that we know. So like here, 13 to the negative 4 times 13 to the 7th. Do not move your negative exponents until you've combined it with everything else. It will just make life so much easier because we don't even actually have to deal with the negative exponents here because they have the same base. I'm just going to add exponents. So this becomes a positive 3, right? So nothing changed. I didn't have to move anything, okay? So unless a negative exponent appears in your final answer, just leave it be, okay? Again, we just did this problem up above. I don't know why it's written twice. So x to the negative 7 over x to the 4th. I like to write it where it's top to bottom here. So again, I'm going to subtract my exponents because I'm dividing. So negative 7 minus 4 is going to be x to the negative 11. I don't like a negative 11, so this would become 1 over x to the 11th. Okay? Anytime I see a division sign like this, please, please, please rewrite it like this. It makes life so much easier. So then I'm looking at my coefficients, and coefficients are different than exponents. 9 over 3 is just like a normal fraction that reduces to 3, and we're done. Now I'm going to say there's an invisible exponent of 1 with this m, so I would have 1 minus negative 2, and I'm going to write that because that'll just help keep my brain straight here. And 1 minus negative 2 is in fact 3. So I didn't have to move any negative exponents. They were already dealt with the other properties, okay? So 3m to the 3rd, okay? Go ahead and try this one on your own and come back to the video. So again, I just like to rewrite it so it's top to bottom. This would be y to the negative 3 minus 5. And negative 3 minus 5 would give me negative 8. I do not like negative exponents, so I'm going to go ahead and move that down to the denominator. Okay? I hope you have a wonderful day, and we'll talk to you later. Bye.